Before watching the video, do subscribe my channel and hit the bell notification icon to get the instant updates. So after the gaseous state, we now move to the next state of matter, that is liquid state. What are the common properties? The intermolecular forces are weaker as compared to solids but stronger as compared to gases, due to which the intermolecular distance is intermediate, meaning lesser as compared to gases and more as compared to solids. What about the volume in case of liquids? They have a fixed volume but no fixed shape, because when you pour the liquid into another container, it acquires the shape of the container, because liquids have a property to flow. So they are basically referred as fluids. Liquids have the property to flow and referred as fluids. Clear? Now there are many important properties of liquids, out of which 3 important properties we are going to discuss here. The first property is vapor pressure. Vapor pressure. This is in lines with a concept of physical equilibrium, which I had discussed in equilibrium chapter. So physical equilibrium is an equilibrium established between the physical states of the same substance. If the substance is water, then the physical states water and gas. If there is an equilibrium established between them, it is called physical equilibrium. And for that we need to consider the water in a closed container. Okay, let's understand. So now to understand the vapor pressure, we consider a container which is closed and it is filled with a liquid, partially filled with a liquid. Let's consider water. And this part is connected to vacuum pump, so that whatever gas was present inside the container would be sucked out. So now in the container we have liquid filled to a particular level, partially filled. Now if I allow the container to be at this state only, what will happen? Nothing. Hoga. There is just liquid placed in a closed container and the gas inside that is being sucked out through the vacuum pump. In the liquid, we know that the molecules of the liquid have some intermolecular force of attraction. Because of that intermolecular forces of attraction, they have some kinetic energy. It may so happen over a period of time that the kinetic energy of the molecules which are at the surface have more energy as compared to the molecules which are below it. Because of that, at some point of time they can get converted into the vapor state and escape from the surface as vapors. If we have water in some closed container and the gas is being sucked out, over a period of time, what will happen? Because the molecules have kinetic energy, here the molecules are not colliding with the walls of the container, but still they are colliding amongst each other, because of which there is loss and gain of energy which is possible. So it may so happen over a period of time that the molecules at the surface acquire energy which is higher than the molecules in the bulk, and those molecules now can get escaped into the vapor state. Correct? So now if I measure the pressure corresponding to this via a manometer. Manometer is simply a tube which is used to measure the pressure with the level of the mercury. So this is called height of mercury column. So this is how we actually measure the atmospheric pressure also, in terms of height of the mercury column, where the height is 760 mm of Hg. So when this rises up to 760, the pressure is considered or is equated to 1 atmosphere. So initially the level would be same. Now the molecules, as soon as they escape into the vapor phase, these molecules will collide with each other and also collide with walls of the container, due to which it will exert a And here if we measure the pressure, the level will rise, meaning the pressure is increasing. Correct? So as the time passes, more and more molecules of the water, liquid water, will get converted into the vapors. Clear? So the pressure will go on increasing. Will there be a limit, or the pressure will go on increasing? What is the limit?
Very less molecules of
When they are
water.
equal, so water molecules and the gaseous molecules are equal.
To the
Till they are equal.
When they
Till they are present.
what are equal?
the
Both are equal.
gas molecules and the water molecules.
Yeah. Are equal.
The molecules which are, now what happens, slowly हम लोग बात करते हैं. So as soon as the molecules are escaping into the vapors, they are creating a pressure on the wall of the container. So the pressure is going on increasing. This pressure exerted by the vapors is basically called as vapor pressure. So initially this pressure measured by the manometer will go on increasing. Clear? As the molecules of the vapor increases, there may be a case wherein the molecules, because of the collision, are losing their kinetic energy, and at some point of time the kinetic energy is so less that they can get back converted into the liquid state. The reverse process is called as condensation. So initially the molecules were evaporating, and as the evaporation goes on, the condensation also starts. If I graphically explain you this, then I'll draw a graph of rate versus time. The rate of evaporation for any liquid is always constant. The molecules evaporate always at a constant rate for a particular liquid. मतलब इनिशियली जो मॉलिक्यूल्स एवेपोरेट हो रहा है उनका जो स्पीड है वो इवेपोरेशन का कांस्टेंट ही रहेगा. लेट्स से द रेट ऑफ इवेपोरेशन इज दिस व्हिच इज कांस्टेंट. नाउ एट टाइम t equal to 0, आर द मॉलिक्यूल्स कंडेंसिंग? नो. एज द टाइम passes, they will lose the kinetic energy and the molecules can get converted into the liquid state, so they are starting to condense. So now as the time passes, the condensation increases, and at some point it will become equal to the rate of evaporation. This point where the rate of condensation is equal to rate of evaporation is called physical equilibrium, and at physical equilibrium we say the vapors are saturated. The vapors are saturated because now the number of vapors which are there in the gaseous state is equal to the number of vapors which are getting converted into the liquid state, meaning the rate of evaporation becomes equal to the rate of condensation. So now even if the molecules are increasing, at the same time they are decreasing. So the pressure which is measured now in the manometer will become constant. It will initially increase, but at the equilibrium point it will become constant. Hence vapor pressure is constant at a constant temperature for a liquid.
So now the condensation is always equal to evaporation after equilibrium.
Yes. Once the equilibrium is reached and the equilibrium is not disturbed, it will be in equilibrium forever. So अब अगर 50 molecules evaporate हो रहे इस point पे, तो 50 molecules will condense, 60 molecules 60 molecules, 100 तो ये equilibrium fix रहेगा. If I heat up this container, what will happen? The rate at which the molecules are evaporating will be higher. The equilibrium will be achieved at a faster rate, and the pressure exerted by the vapors would be now higher. So higher the temperature, higher will be the vapor pressure. If I heat up this container, then the molecules which are evaporating will evaporate at a faster rate. The equilibrium will be achieved faster. The pressure exerted by the molecules would be higher. So if I increase the temperature, I am actually increasing the vapor pressure. So vapor pressure is dependent only on temperature, and it is fixed at a fixed temperature. It increases with increase in temperature and vice versa. Clear? Yes or no? Now let's understand this concept of vapor pressure with respect to boiling point. Very interesting concept. Listen. If I now consider the same container filled partially with the liquid water, but now the container is open. First thing, the container is open. Second day, I am heating the container. Okay? I have kept the container open and I am heating the container. So what will happen? Evaporation. Now these molecules which are escaping into the vapors phase, are they coming back? Not condensing. But these vapors which are getting created, they are going up against something, against the atmosphere. We know that the atmosphere creates a pressure on everything because the weight of the air as it comes down increases. The weight of the air as it comes down increases, hence it creates a pressure. At sea level, this atmospheric pressure is 1 atmosphere, which we have considered to be the standard pressure. If we move higher altitudes, the weight of the air is lesser, air is thinner. That is why the pressure at higher altitudes is lesser. So when you move to hill stations, the pressure over there is lesser. When you come to sea level, the pressure is higher. So basically now these molecules are evaporating, but they are evaporating against a pressure created by the atmosphere, which we call it as the atmospheric pressure. So this atmospheric pressure will push the molecules, some molecules of the vapors to convert into the liquid state, meaning condense. So again, there is going to be a point of equilibrium which will be reached at some point of time. And at that point of time, it may happen that the pressure which is created due to the vapors and the atmospheric pressure becomes equal. So the point at which the vapor pressure becomes equal to the atmospheric pressure, now I can say the equilibrium is established, and at that time the molecules start boiling. This process would be now referred as boiling, and the temperature at which the liquid starts boiling would be called as the boiling point. We have defined the boiling point in simple words as the temperature at which the liquid gets converted into gas. But boiling point is actually the temperature at which the vapor pressure of the liquid, any liquid, becomes equal to the atmospheric pressure. So at that point of time, even the molecules which are present at the bottom of the container will start boiling. Very good. If you have observed the water ka boiling, then at the bottom, even the molecules at the bottom will be converted into the gaseous state. Bubbles form hota hai. So bubbles jaise form hota hai, you say the liquid has started to boil, and that is what is the boiling point of the liquid. In case of water, it will be 100 degrees Celsius. Now, if we consider the boiling point of water at 1 atmosphere, we know the boiling point is 100 degrees Celsius. We need to heat the container or the vessel up to 100 degrees Celsius for it to boil at 1 atmosphere. This boiling point at 1 atmosphere is referred as normal boiling point. So normally we say boiling point of water is 100 degrees Celsius. But if I take the convention to be 1 bar pressure, so which is lesser, 1 bar or 1 atmosphere? Obviously 1 bar, because 1 bar is just 10 raised to 5 Pascal, but 1 atmosphere is 1.01325 into 10 raised to 5 Pascal. It's approximately same, but still comparatively 1 bar is a lower pressure. Now understand, if the atmospheric pressure is lower, then the amount of heat required to boil will be lesser. So at the lower atmospheric pressure, the boiling point is lower. Understood? Listen now. So at 1 bar, when we measure the boiling point of water, it's found to be 99.6 degrees Celsius. And this is called as standard boiling point. So the concept is simple. At 1 atmosphere, the boiling point is 100 degrees Celsius. At 1 bar, the pressure is lesser. So the amount of heat required to boil would be lesser, because I'll require less heat to create or to equate that atmospheric pressure. Hence the liquid will boil at a lower temperature, and this is what happens at higher altitudes. So if you are heating the vessel at sea level in Mumbai, and if you are heating that same liquid in the vessel at higher altitude, Lonavala, Khandala, so the boiling point of the water at higher altitudes would be lesser. It will boil faster. It will boil faster. Hence it's very difficult to cook the food at higher altitudes in an open vessel. So to deal with this problem, pressure cooker was introduced. So what happens in pressure cooker now?
प्रेशर बढ़ता है तो टेम्परेचर ज़्यादा बॉइलिंग पॉइंट बढ़ जाता है पानी का, प्रेशर बढ़ता है उसके।
हाँ, it's a closed container.
सबसे पहले pressure cooker is combination of these two things. Pressure cooker is a closed container and we are supplying heat. So the two concepts which I discussed, combination of that is nothing but the concept behind the pressure cooker. So if the container is closed, the pressure inside the system is now very high, immeasurable. You don't know what is the amount of the pressure inside because it's a closed container. Now the atmospheric pressure, is it in the picture? No, it's eliminated. अब जो pressure create हो रहा है वो बहुत ही ज़्यादा है. Correct? So now we will heat a pressure cooker to cook the food in the other vessels. We use water. Correct? So what is the significance? When we are heating, the water will start evaporating and it will try to match up the pressure inside the pressure cooker. But since it is very high, it will take very long time to actually boil. In fact, since the pressure is immeasurable, we say in pressure cooker the boiling is actually not achieved. If it is measurable, I can say it will be achieved at a particular temperature. Since it's a very high pressure, the boiling is actually not achieved. It's continuously the evaporation, and it will evaporate till the water which is present inside the pressure cooker. Am I clear with that phenomena? Yes or no? So this concept of vapor pressure is first used in pressure cooker. Secondly, they are used in autoclaves. Autoclaves are basically the devices used to sterilize the equipments, the medical equipments. Sterilize करते हैं ना, जैसे syringe है या जो disposable items हैं उनको स्टरिलाइज या डिस्पोज करने के लिए ऑटोक्लेव्स यूज होता है. ऑटोक्लेव्स में बेसिकली लिक्विड को हीट तो करते हैं, बट एट द सेम टाइम द एक्सटर्नल प्रेशर इज इंक्रीज्ड बाय पुटिंग वेट्स ऑन इट. द प्रेशर इनसाइड दैट इज very हाई, सो द लिक्विड विल टेक वेरी लार्ज पीरियड ऑफ टाइम टू एक्चुअली बॉयल. तो वो बॉयल एक्चुअली होगा ही नहीं या बहुत हाई टेम्परेचर पे होगा, जिसकी वजह से वो स्टरिलाइजेशन के लिए जो वेपर्स मिलेगा दैट एट अ वेरी हाई टेम्परेचर. Understood? So these are few of the applications which I have discussed with respect to first property of liquid, that is vapor pressure. Understand this in a sequence. I first took a closed container and heat was not supplied. Over a period of time, the molecules of the liquid will start escaping into the vapor state, will create a pressure. This pressure will go on increasing till a point of equilibrium. So hence now at equilibrium the pressure will become constant, and this pressure exerted by the vapors in the state of equilibrium will actually be called as vapor pressure. This is also called as saturated vapor pressure or equilibrium vapor pressure. Saturated or equilibrium vapor pressure. Clear? Then I consider the container to be open and I heated the vessel. In that case the molecules will start evaporating, but now they are evaporating and trying to escape out of the vessel. But then there is a atmosphere which is creating a pressure, due to which the molecules will start condensing. In this case there will be an equilibrium established at some point, and that point basically will be called as the boiling point. So boiling point is defined as that temperature at which the vapor pressure becomes equal to the atmospheric pressure. So this atmospheric pressure is creating the pressure on the entire bulk of the liquid, no? So because of which the molecules at the bottom will also try to escape or boil in the vapor state, and that is where the bubbles appear. Clear? And now the combination of these two, meaning when the container is closed and we are heating, is a phenomena used in pressure cookers. Also, at higher altitudes the pressure decreases and the boiling point also decreases, because we will require less heat to boil the liquid.